In this video, we are going to go deeper into the meaning of error code 88 in air conditioning units, a particular code that generates many doubts because it does not have a unique or universal meaning. Its interpretation depends directly on the brand, the model, the technology of the equipment, and the self-diagnostic logic that each manufacturer incorporates into their electronic systems. What can be stated based on field experience is that, in most cases, 88 must be interpreted as an electronic symptom. This can manifest itself from something very simple, such as a transient display on the screen that does not imply a real fault, to a serious problem in the power electronics of the unit that prevents normal operation. It is frequently related to problems with the power supply and unstable voltage, communication errors between the indoor and outdoor units, or failures in the control board, the EEPROM memory, or the inverter module. In other words, 88 does not point to a single cause, but to a range of possible scenarios that must be carefully verified. If we analyze the behavior of code 88 by brand, we find notable differences that are important to be aware of. In the case of Samsung, this code is usually associated with voltage problems, corruption in the EEPROM memory, errors in configuration options, or control board lockups. It generally appears after a sudden power outage, electrical fluctuations in the grid, or internal failures in the memory that stores the unit's operating parameters. In practice, the first recommendation is to perform a full reset, disconnecting the air conditioner from the power supply for several minutes before energizing it again. If after this procedure the error persists, the next step is to measure the line voltage to verify that it is within the nominal range and, if necessary, check the physical and functional integrity of the main control board. In Daikin, 88 is related in several series of units to abnormal readings of the discharge sensor, specifically the one that measures the temperature in the compressor discharge pipe. The code is activated when the sensor delivers out-of-range values, either due to electrical problems in the power supply, sudden voltage variations in the grid, or defects in the sensor itself. In this scenario, it is essential to first rule out any electrical anomalies in the installation before proceeding to replace the part. To test the temperature sensor, the most recommended procedure is to disconnect it from the electronic board and measure it with a multimeter in the kilo-ohm scale. When placing the multimeter probes on the sensor connector, the resistance value should not read 0 or infinity. Ideally, the measured value should correspond to what the service manual specifies. If the manual is not available, a practical test can be applied. Touch the sensor with your hand or rub it gently. In that case, the electrical resistance in kilo-ohms should gradually decrease, confirming that the thermistor is responding correctly. For carrier, code 88 is often linked to VFD or variable frequency drive or inverter module lockups and to errors in the DC link sensors. These types of events are much more delicate as they directly affect the power electronics responsible for controlling the compressor. The repair usually requires specialized inspection, which includes checking the condition of the inverter, verifying that the module has adequate ventilation to avoid overheating, and assessing whether it is necessary to replace internal components. In many cases, this type of failure requires the intervention of a certified technician with experience in inverters, due to the complexity and electrical risks involved. In MrCool, 88 normally indicates power supply problems or communication wiring issues between the units. It is quite common for this error to appear when the wires are reversed, the connectors show physical damage, or there is a failure in the control board that prevents stable communication. The diagnosis must be done meticulously. First, check the continuity of the conductors. Then, make sure there is no phase reversal in the communication wires, and finally, verify the condition of the board. If, after these verifications, the error continues, the solution is usually to replace the electronic board. In brands such as General Electric, Amana, and TCL, especially in window and portable units, code 88 tends to be interpreted more as a transient display state after a blackout, an overvoltage, or a similar electrical event. It can also be a sign of a failure in the control board. In these cases, the initial recommendation is simple. Perform a complete reset and verify that the power supply is stable. If after these actions the error does not disappear, the proper step is to proceed with a deeper inspection of the electronic board and assess whether it requires repair or replacement. In manufacturers such as Haier, Midea, Mabe, and Mirage, and Orient, code 88 frequently appears as an electronic or communication symptom. Very often it is associated with unstable power supply, low voltage, or electrical disturbances that cause temporary lockups in the control board. It is important to mention that in brands such as Mirage and Mabe, there is not always official documentation that clearly defines the exact meaning of 88. However, field technicians have reported that this code appears after electrical storms, voltage drops, or grid fluctuations, and, in many cases, corresponds to transient electronic lockups or the activation of all display segments. In summary, it is an indication that the board has received an abnormal signal and reacted by showing 88 as a protection symptom. In summary, among the most common causes that generate this code for most brands, the following stand out. A. Unstable or low voltage as well as power surges and outages, which is especially frequent in Mirage, Mabe, Haier, and Orient units. B. Lockup or corruption of the EEPROM memory or of the control board itself that loses operating parameters. C. Inverter failure or lockup in inverter-type units, particularly in certain carrier series. D. Communication errors between the units due to loose connectors, damaged wires, or reversed cables in the installation. E. Faulty sensors, such as thermistors out of range or actuators that do not respond correctly to system commands. F. Transient display states where all segments light up showing 88.88 after a major electrical event. Practical and safe diagnosis must be carried out in well-defined steps to avoid mistakes. A. Perform an initial reset by disconnecting the power for at least 5 to 10 minutes and then re-energizing the unit. B. Measure the line voltage at the unit's box, ensuring there are no drops, spikes, or values outside the nominal operating range. C. Test the unit on another electrical circuit when possible, in order to rule out any problems in the original electrical installation. D. Check connectors and wiring, always with the power off, verifying that the communication wires between the indoor and outdoor units are in good condition, correctly positioned, and free of visible damage. E. If communication problems between the indoor and outdoor units of the air conditioner are suspected, with the unit turned on, locate the signal wire and measure the signal voltage in the DC voltage scale. If there is signal, the measured voltage value should be intermittent. F. Inspect the PCB visually, looking for signs of moisture, corrosion, insects, damaged solder joints, or burnt components. In conventional, non-inverter boards, it is advisable to measure the input and output voltage of the transformer as well as the voltage after the rectifier bridge. In inverter boards, on the other hand, the proper powering of the intelligent power module must be checked.